Hello, Assalamu alaikum. In today's video, we are going to end our first topic, quadratics, and I will try to start the next topic also. So, first, let's review what we had done in lecture 1 and lecture 2. In lecture 1, we had discussed what are polynomial equations in detail and what are three conditions for the polynomial equations: one or more variables, sum of terms, positive integer, power of variable. Then we discussed what are roots, answer or solution, and we discussed coefficients. Like here is one coefficient, there is -5 coefficient, and there is 6 other coefficient. Then we discussed that we have 4 topics: quadratics, cubic, quartic, substitution, and after that we can gain 7 to 8 marks out of 75. Today we will try to end up quadratics, then we will start the cubic inshallah. Then we started the quadratics, in which we had discussed 2 degree of polynomial and its general structure is ax square plus bx plus c. Then we derived two formulas. Derivation is not part of the syllabus. Sum of alpha equal to -b upon a and alpha beta is equal to c upon a. Then we solved a question using these two formula, and then we derived one more formula, that sum of alpha square equal to sum of alpha whole square minus 2 alpha beta. Then we solved a question using that formula. Then we move further ahead and solved further questions. Then after that, today I'm going to introduce you one more formula. Then we will do one more question using that formula, and we will do total 3 questions today, and then I will try to move to cubic in today's lecture. That's my target. Okay, so wait for a bit. So I will tell you that if the question asks for 1 upon alpha plus 1 upon beta, then what will we do? Basically, we will multiply this to this and this to this. Let me show how. If we multiply beta to that, it becomes beta, and alpha to this, it becomes plus alpha, and then in denominator they both get multiplied and become alpha beta. Okay, so we can write this as alpha plus beta and alpha beta. Okay, then we can also write this like 1 upon sum of 1 upon alpha equal to sum of alpha upon alpha beta. And wait for a bit, let me move it downwards. We can also write it like this: sum of alpha minus 1 equal to sum of alpha upon alpha beta. Why sum of alpha? Because alpha plus beta is sum of alpha. We had discussed in lecture 1. Okay, so now I'm moving with the question. Here the question: the quadratic equation x square plus 2x minus 6 has roots alpha and beta. Find the values of alpha minus beta whole square and 1 upon alpha square plus beta square. So, point to be noted, we didn't learn any formula for this. Because these are rare questions that are not common questions. So, the new thing can appear in the exam. So we just need to use our basic algebra to derive the formula. Let me show in this condition, if this question appears in the exam, what will you do? Okay, so first of all, let's expand these. Let's say we have alpha minus beta whole square. We know that a minus b whole square is equal to a minus 2ab plus b square. We just use this alpha square minus 2 alpha beta plus beta square. Okay, then we can get our formula that alpha square plus beta square minus 2 alpha beta. So are we getting? We are with our formula that sum of alpha square minus 2 alpha beta. This is our formula to do this part. Okay, do you have any problem in this deriving the formula? The question gave this alpha minus beta whole square. We used a square minus 2ab plus b square, and then we got this alpha square minus 2 alpha beta plus beta square. We arranged it like this, so we got sum of alpha square minus 2 alpha beta, which was the remaining term here. So that's our formula to solve this question. But currently I'm not solving this. I am going to derive the formula for this also. Okay, so to derive the formula of this, what the question gave us, 1 upon alpha square plus 1 upon beta square. This is the question which is asking. So what we will do, we had learned this will get there, this will go there. Okay, we had discussed this, so it become beta square plus alpha square, and in denominator product of both alpha square beta square. We can write this as sum of alpha square upon alpha beta whole square. Okay, so we are at a good point. We know what we need. We need sum of alpha square and we need alpha beta to solve these two things. So first of all, what we will do, we want sum of alpha square. Sum of alpha square equal to sum of alpha whole square minus 2 alpha beta. Okay, so for this we will find sum of alpha. Sum of alpha equal to let's find. First of all, let's get what is a equal to 1 here, b equal to 2, and c equal to minus 6. 1 2 minus 6. Okay, so for sum of alpha we have the formula negative b upon a. We know this. Okay, so b is 2, so negative 2 upon a is 1. So sum of alpha equal to negative 2. Okay, we also want alpha beta. To find alpha beta we want c upon a. So c is negative 6 and a is 1. So let's write negative 6 upon 1 means negative 6. Okay, but we have to find sum of alpha square to give the answer what the question requires. So sum of alpha square we are going to find out here. It is equal to, what was sum of alpha? Negative 2. So negative 2 whole square, then minus 2. What was alpha beta? Alpha beta was negative 6. So now we will get sum of alpha square. So it is 16. Sum of alpha square is 16. Now let's find out alpha minus beta whole square equal to sum of alpha square, which is 16, minus 2 alpha beta. Minus 2 alpha beta is equal to negative 6. So it is equal to, let's calculate here, 16 plus 12 is equal to 28. So that's our answer. Sorry, 28 is our answer. Then we have to find out sum of 1 upon alpha square. What was the formula for this? Sum of alpha square, which was 16 upon alpha beta, means minus 6. Okay, so this is equal to, not, wait, here is a mistake, alpha beta whole square. So here will be square in the denominator. Give me a time. Yes, minus 6 whole square. So it will be 16 upon 36, which is 4 upon 9, our answer. Let me give you a review of this question, how we solved this. Before that, let me rub this. Yeah, so he asked for in bracket alpha minus beta whole square. We don't have any general formula for it, so we expanded it using our basic algebra, and then we got our formula. Then we find sum of alpha square using our formula, sum of alpha whole square minus 2 alpha beta, and then we also find alpha beta, and then we inserted sum of alpha square and minus 2 alpha beta in this formula, and we got the value 28 for this. Then it was asking for one more thing, which is also new for us, 1 upon alpha square plus 1 upon beta square. We don't have any general formula for it. We just derived the formula for it, like multiplied they both, so they become beta square plus alpha square upon alpha square beta square. Through this we got sum of alpha square upon alpha beta whole square, and we had recently find out the values of sum of alpha square and alpha beta, so we just inserted into formula and got the answer 4 upon 9. I hope you get it. If you didn't get it, you can go backward and repeat it how we solved it, so you can get it. Let me move to the next question. Yes, so in this question, the quadratic equation 3x square plus 2x minus 4. So a equal to 3, b equal to 2, and c equal to minus 4 has roots alpha and beta. Find the value of s1, s2 and s minus 1. So what is s1? Basically, let me write here, s1 is sum of alpha. Before that, let me tell you in a general form. Oh, wait here. Wait for a bit. I was not expecting this. That's my mistake. Sorry. Wait, where I am stuck. I don't have much time to waste on this. You can skip this part. Sorry. Yeah, so this is, yeah, so I was writing this, that Sn can be, is basically this sum of alpha n. Okay, so if it is asking for s1, we will write sum of alpha. If it is asking for s2, it means he wants sum of alpha square. If he asks for s3, it means he asks for sum of alpha cube. Okay, so wait, let me move this question 10 below to get space. So what it is asking, and one more thing, it is asking for s minus 1. So let me write minus 1 here. S minus 1, it means sum of alpha minus 1. I hope you are getting this. So now solve for S1. S1 equal to sum of alpha, and the formula for sum of alpha is negative b upon a. Wait here. So what is negative? Sorry. So what is b and a? B is 2, so negative 2, and a is 3. So answer is negative 2 upon 3. Okay. So it is asking for S2 also. S2. It is sum of alpha square. We know the formula that sum of alpha whole square means, sorry, let me write the formula here. Sum of alpha whole square minus 2 alpha beta. We don't know the value of alpha beta. So wait for a bit. Yeah, so we don't know the value of alpha beta. First, let's wait. There's a mistake in the formula which I had wrote down here. Wait. That was bracket here. Alpha square minus 2 alpha beta. Sum of alpha is equal to negative 2 upon 3 whole square. Now I will catch speed. So please please stay with me. Minus 2 alpha beta is equal to c upon a negative 4 upon 3. So this is equal to 28 upon 9. Let me confirm it also. So yeah, it is 28 upon 9. And now it is asking for s minus 1. At least I have to end these questions in this video. So it is sum of alpha minus 1. We had learned the formula that sum of alpha minus 1 is equal to sum of alpha upon alpha beta. Okay, so sum of alpha we had find out as minus 2 upon 3, and alpha beta we had find out as negative 4 upon 3. So we got it as 1 upon 2. So that's our answer. So now move to our last question of this topic. After that we will move to the next topic, cubic. I think we can't move today. But before the last question, I want to tell one more thing. So make a space again. Yeah. So alpha square plus beta square. Okay. So think one thing, that if we insert alpha equal to 1000 and beta equal to 10,000, and square here also, so we will get a positive value. Okay, if we insert negative 1000 here and whole square plus negative 10,000 here and whole square, we will still get a positive value, which shows that sum of alpha square plus beta square is greater than 0 for all real values. And if I say values are alpha and beta, so there will be nothing wrong. But I am going to tell you one thing. Yeah, so I want space again. Yeah, what if alpha square plus beta square is negative, it's less than 0? It means values are not real. They are complex. Wait. They are complex. Okay. Wait, let me write they are complex in the next line. Just give me 2 minutes. Not 2 minutes. We don't have much time. Okay. So they are complex. So the values are complex. Not real means complex. We know this. Okay, so let's do our last question of the first topic, quadratics. Yeah. So the question is, you are given the quadratic equation 4x square minus x plus 6 equal to 0, which has roots alpha and beta. So let's write a equal to 4, b equal to minus 1, and c equal to 6. Okay, and he asked to find out sum of alpha square sum of, wait, it's a part a, let me write it. Sum of alpha square is equal to bracket sum of alpha whole square minus 2 alpha beta. So sum of alpha, we have to find sum of alpha. So to find out sum of alpha, we know the formula negative b upon a. Negative b means negative 1 upon 4. So it is equal to 1 upon 4. And alpha beta, here is alpha beta, which is c upon a, means 6 upon 4, which means 3 upon 2. Okay, so sum of alpha square we can find out now is equal to 1 upon 4 whole square, means sum of alpha whole square, minus 2 alpha beta means 3 upon 2 here. So what we are getting? We are getting minus 47 upon 16. Okay, so that's our answer. In part B, it is asking, without solving the quadratic equation, state what your value for part A tells you about the roots. Part B. As we had learned that when alpha square plus beta square means sum of alpha square is less than 0, it means values are not real. So the values are complex. So we will just write they are complex roots. they are complex roots since sum of alpha square is less than 0. So that's our answer. And what if we solve this equation using middle term? So instead of solve, we can check is it complex or not. B square minus 4ac, let me write minus 1 whole square, 4 4 and 6. So I'm getting 4 by 4 means 16, 16 by 6 is 96. So 1 minus 96, I'm getting minus 95, which shows there are no real roots. There are no real roots, there are complex roots. So thus we can end our first topic quadratics. We can end now our first topic quadratics, and now inshallah in next video we will move to our second topic cubic, in which we will discuss the formulas for cubic, and that will be simple as we had learned the formula of quadratic, so they will be similar, not any new thing. I will tell you what will be new. So thank you for watching with this video. If you get the concept, so please like the video and share and subscribe the video. So thank you for watching this video. Allah Hafiz.